Good afternoon, everyone. Thanks so much for joining again today. It's a real pleasure to speak to you all. 2 o'clock, my favorite time of the day at the moment. So thanks so much for joining in today. It's really nice to see someone saying on Notebook 3 already, what an awesome set of learning we've been doing together and how proud I am to be here working with you each day at 2 o'clock. Now, just before I get going today and before we do some bad boys, we're going to do 4 difficult questions in a row today, straight A-level standard on gradient. Just before I get going, a quick apology about yesterday. I wasn't at my best yesterday. I had a lot going on external to the 2 p.m. session, and I just made a few mistakes and I hadn't checked that the workings weren't on the right hand side of the your turn section. So maybe some of you guys noticed that yesterday that I didn't do my turn, your turn. It's just because I made a little bit of a boo-boo with the slides because I did them so early in the morning. So just want to say sorry for that. We all make mistakes, but again, as I always tell you guys, mistakes are what you learn from. Don't beat yourself up about it. Get back up on the horse, try again, make sure you don't make the same mistake twice. So a little apology before we kick off. Now, we're going to do some tricky questions today. Yesterday was a bit easy. Today it's going to be tricky. We've got to know gradient. We've got to be good at it because these are the questions I found in some of the AS papers. They're not that bad, but they're just a little bit tricky and we need to practice them. So just before we get going, just to remind you, we're doing gradient of a line, the second lesson today. Need your brain, need your pen and paper. Please copy stuff down today. It's less graph work and more algebra. So I want those notes neat. I want things written down nice and neat like I do them to make sure we've got a good methodology and we're not just guessing answers. What did we learn yesterday? Just to recap. If you've got a straight line and we've got 2 points on the straight line, we can work out the gradient pretty easily. It's given by the formula change in y divided by change in x. So what we do is we just write down gradient is change in y over change in x. We work out how far up we've gone from one point to the other and how far across, and we do the change in y over the change in x, and here we'd get 2/3. So that's what we did yesterday. We did loads of that stuff and it was pretty easy. Today, we're going to do the similar methodology, but it's going to be heavily involved in algebra and you've got to have your wits about you, right? So let's get straight in. All 4 questions are exam questions. They're probably going to take us 5 minutes each because they've got pretty meaty algebra in them. Let's go. Here we go. Let's kick it off. A, coordinate 7, 9, little a, and P, coordinate 10, 4a, are 2 points where a is a constant. Write the gradient m in terms of a. Give your answer in simplest form. So this wasn't just like calculate the gradient. It's like give your answer in terms of a, etc. Let's just do what we always do. Let's write down xy to remind ourselves to label things properly. The coordinates of a are 7 and 9a, and the coordinates of p are going to be equal to 10 and 4a, like that. Remember what I did yesterday? I find this handy to do. I remind myself that the x's are all in line and the y's are all in line. And I say to myself, the gradient, its definition, as we just talked about, is the change in y over the change in x. Okay? So what I do is I say, let's do the change in y. 9a subtract 4a, that goes on the numerator, and on the bottom, remember to do it in the same order, 7 subtract 10. So 9a take away 4a is 5a, and 7 subtract 10 is -3. And this is why I'm saying already we're into bad boy zones today. The way to simplify this, 5 divided by -3, just write as -5/3. So our final answer m is equal to -5/3 a, like that. And that is giving the gradient m in terms of a, and we're done. So it's not a simple answer here. It's a bit of algebra on the go. The questions later will get even harder than this, but just to warm us up, it's the same as we did before. Just keep your wits about you. Don't make any boo-boos, and you've got a bit of algebra in there at the end. Just need to tidy up and keep your head straight. Okay, time for you guys to try one yourself. Here you go. Wow, some great answers coming in here. Some people are saying negative 6a over 7 or negative 6 sevenths a. Andrea, Krishni, Gogo, Harry, nice one. Let's see what I got. I don't honestly remember, but loads of you are getting the same answer. I also got negative 6a over 7 or negative 6 sevenths a. Lovely stuff. Now, we got asked a wonderful question in the chat, and I better address it. I can't remember who wrote this, so sorry I don't remember because it just flicked by too quickly. They said, what if I take away in the other order, sir? Will I get the same answer? Imagine, just for example, this one here, I had written 10 and 4a on top, and I had written the 7 and 9a on the bottom. Then, if I do difference in y's, 4a take away 9a on top, and 10 take away 7 on bottom. 4a take away 9a is negative 5a over 3. And that also turns out to be negative 5/3 a. So it doesn't matter what way round you subtract them, as long as you subtract the x's in the same order and the y's in the same order. If you take the y's away in a different order that you took the x's away, you're in big trouble. Big trouble. So what a wonderful question in the chat. Thank you so much for asking it. And I should have mentioned that at the start. Okay, time for our next question. This one's a little bit trickier. It's got a bit more a's involved. Let's have a look. We've got coordinates A, which are 2a and 5. And we've got coordinate P even, which is 7a and 8. And they're 2 points where a is a constant. The gradient m of AP is 6. It tells you the gradient is equal to 6. Right? So here I'm going to keep my x's in line, I'm going to keep my y's in line, and I'm going to state that my gradient is 6. Always write down my formula for gradient just to make sure I've got everything in my mind neat and I'm showing my workings. So the gradient is the change in y over the change in x. Now the gradient here, I'm going to highlight that in blue. The change in y is the difference taking away these y coordinates here, and the change in x I'm going to highlight as green. Now let's substitute what we know in the question. We were told m is 6, so write that bad boy in for 6. Okay, don't hold it in your back pocket. Use it so we can get some workings out of it. The change in y, well, the change in y is 5 take away 8 over the change in x, doing in the same order, 2a take away 7a. Right? So I've done exactly what I did in the last time, other than I knew the gradient was 6. So I'm making sure that's involved. Now tidy up where we can. Therefore 6 is equal to 5 take away 8 is negative 3. And 2a take away 7a is negative 5a. Now we want to solve for a. So we want to make a the subject. So what we're going to do to both sides here is multiply both sides by negative 5a. And what you'll get on this side is 6 times negative 5a is therefore equal to negative 3, because it will cancel out this negative 5a here. That's negative 30a is equal to negative 3, tidying up. And then finally, divide both sides by negative 30. And what you get for yourself here is that a is equal to negative 3 over negative 30. I can divide the top and bottom by negative 3 to simplify, because I was asked in simplest form. And I get, I'm going to write over here because we're running out of space, a would therefore be equal to 1/10. Okay, so hopefully you can see there's a lot more trickiness going on here. Because you've got a's on the denominator, you've got to do a lot more algebra, multiply up and all sorts of things, and at the end simplify a fraction, and negatives are involved, all sorts are involved. So hopefully that helped. A little bit different question because you were given the numerical value of the gradient here. M was 6. In the last one we were told to work out m, so a bit more tricky. Let's see if you guys can do all by yourself now. Here you go. Wow, loads of awesome answers here. Asmal, Edward, Daniel, Mariam. So many similar faces come back over and over again. Imran, Ethan, Jack, Suman, Vanessa. Wow, Libby, Mushi, Vulpez, Harshina. Sorry if I'm not saying everyone's name. Lakshman. Maisie, how many marks would it be? Maybe 3, maybe, Maisie. There's a few steps involved here. So let me see. I can't remember if I got A is equal to a quarter. Let me have a look. I also did get A was equal to a quarter as well. Absolutely excellent job, everyone. I'm really proud of you. Okay, next one today. Next one's another exam standard question, similar to this, but there's even more algebra to tidy up at the end. So make sure you've got plenty of working for this next one. It's going to require some pages. We're going to need some paper, people, to get through this one. Here we go. We have 2 coordinates here. We've got A is equal to -3, 6. We've got P is equal to A and 2A. And we're told that M, the gradient of AP, is equal to 4. So we've got all sorts of things on the go here. So I'm going to write that like that. And like that. And just remind myself that these were the X and Y coordinates. So I start off by stating my formula. Always do this. Gradient is change in X, or change in Y, sorry, over change in X. Actually, I'm going to teach you a little trick here. In A level, we write delta Y over delta X. That delta means change in Y over change in X. I might just do that for now to save me a bit of hassle. You'll see that in A level most likely. So the change in Y is going to be 6 take away 2A, 6 take away 2A, all over -3 subtract A. And remember, in the question you were told M is 4. So don't write M here, write 4 instead. So all I've done is use all the facts in the question. Now this is where it gets a bit tricky, right? You've got to have your wits about you here. This denominator, I want to get rid of it. And so what I'm going to do is I'm going to multiply both sides by -3 subtract A. So I'm going to multiply both sides by -3 subtract A. Like that. So keep that 4 here and put a bracket. -3 subtract A is equal to, if I multiply the right by that, the denominator just vanishes, or like you just get 1 on the bottom. So here I'm going to get 6 subtract 2A here. Then I'm going to expand the brackets. So I'm going to get myself -12 subtract 4A is equal to 6 subtract 2A. And I want to get the A's all by themselves on one side and the numbers all by themselves on the other side. So if you can bear with me and do this in one move, I'm going to add 2A to both sides to get rid of that -2A. And I'm going to, at the same time, I'm going to add 12 to both sides to get rid of that -12. So I'm going to add these to both sides. So add 2A, add 12. That will get rid of that. And it will get me a 2A on this side. Keep that -4A over here. And it will give me, on this side, it will give me 6 add 12, which is equal to 18. And that -2A will disappear. 2A subtract 4A is -2A. So -2A is 18. Therefore, A is equal to 18 divided by -2. And that simplifies to A is equal to 9. Hopefully that didn't cut the page out. A is equal to -9, I should say. A is -9. Positive 18 divided by -2 is -9. So there's a lot going on here. I might have jumped a few steps here. So if you're not familiar with this linear algebra, how to solve that, maybe we could do another session one day, or maybe you could go to Hegarty Maths and look at my other videos on this. I did 2 moves in one here because I'm running out of paper space. Hopefully they're all right to you. You could have added 2A to both sides separately and then added 12 to both sides separately if you wanted to do it in different steps, as long as you got the answer A is -9 at the end. Okay, over to you. Here we go. Solve for A. Mariam, Vanessa, Lois, Imran, Suman, Rory, Ethan, Branwen, Edward, Abdul, Amit, Gansham, George, Ethan, Jack, Mushi, Hashina, William. Wow, loads of negative fives here. We're either all wrong or we're probably all right. Hopefully, we're all right. Let's have a look. I got A is -5 as well. Happy, happy days. A is equal to -5. Now, bear in mind, guys, I picked these all up from AS papers. So you get 2 or 3 marks for these. So they weren't at GCSE level. Although they're a GCSE skill gradient, you need to know that at GCSE. These questions actually did pick up from an AS paper. So we're doing some genuine exam questions here. Not sure I could count these as bad boys compared to some of the indices well, God, some of those indices we did like last week. Wow. But the last one is tricky. Don't get too confident. The last one is tricky. Here we go. Last one of the day. Leave us a bit of time because it is a bit tricky. Not sure if it's a bad boy. You tell me at the end if it's a bad boy or not. So, again, we've got 2 points, A and P. Where A and B are constants. There's a B in this bad boy as well. There is a bit more tricky, actually. Hold on. Don't get too confident. So, X, Y. I'm going to write it like that. I'm going to write A is -2, 4, and I'm going to write P is AB. And we're told the gradient of M of AP is 3, so M is equal to 3. So just going to highlight stuff, give myself a bit of thinking time, try not to stress out, try and keep the heart rate down, not to get all panicked. Then I'm going to write my formula for the gradient. I'm going to use the delta, the triangle. I'm going to say it's the change in Y over the change in X. Save me some writing. Now, the change in Y, let's do that very, very, very carefully here. So it's going to be 4 take away B. 4 take away B. If I started at 4 when I do the change in X, I've got to start from the -2 here. So on the denominator, the change in X is -2 subtract A. And the gradient was 3, so I can slot 3 in there. And just to highlight it all, the 3 was the gradient given in the question. The change in Y is the numerator and the change in X is the denominator. The question asked, find an expression for B in terms of A. So from this bad boy here, essentially what we're just being told is make B the subject of the formula. We can do that, no problem. So in order to do that, let's multiply both sides by -2 subtract A. That's to remove this denominator, to make it 1. So on the left-hand side, that 3 will stay, but I'll get brackets, -2 subtract A is equal to, I just end up with a numerator, 4 subtract B. Then I'm going to expand these brackets. 3 times -2 is -6. 3 times negative A is -3A. And the right-hand side is just 4 take away B. I'm going to take away 4 from both sides to get rid of this +4. So I'm going to take off 4 from both sides. So when I do that, I will get -6. I'm going to write that in, take off another 4, subtract 3A is equal to, and this is where people go wrong, not B, but -B. That negative is still floating around causing us problems. Tidying this up, -6 subtract 4 is -10. So -10 subtract 3A is equal to -B. Now, we were asked not to find an expression for -B, but to find an expression for B. So to tidy this up, to change -B into a positive B, I can multiply both sides by -1. That just changed the sign of each term. So this here would become positive B, this would become +10, and this would become +3A. And basically we're done. The only thing I want to do is I want to write the B as the subject on the left. It's just neat. And sometimes I write the algebra first. You can write 10 add 3A, but I'm just going to write 3A add 10. I like to make the algebra first just for neatness. It's not wrong if you wrote 10 plus 3A, so don't stress out. I've just written it like that. So was it a bad boy or not? I'm not sure. Do you know what? I'm not sure. I'm not sure if it was. I think there was a lot of negatives on the go personally. And when you're under pressure And when there's a lot going on and you've got gradient and we've got algebra and we've got negatives, it's easy to make a slip up. So maybe it's not a genuine bad boy, but it's one we should practice. It's one we shouldn't get wrong. It's one when the time comes and you see this ever in an exam or whatever, you nail it because we went, oh yeah, we dealt with those ones before. So the true test if it's a bad boy actually is if you get it right or wrong. So here we go. The true test. Here we go. Finn, I need to go for a power walk to cope with these bad boys. Finn, I needed a power walk after yesterday's 2 o'clock session when I just lost the plot. So I know what you mean. Actually, I go for a power walk every day with my little one when she wakes up. We're not power walk; she's on my shoulders, but it's good. It's also good if you can, guys, for your exercise to get a bit of fresh air at this time. It's really good for the mental health. It is Mental Health Week this week. Look after your brain as well as your body and your maths. It's very, very important in life. So anyway, loads of answers in here. I've lost a bit track. I got sidetracked there by a good comment. Some people are saying 4A add 10. Some people are saying 4A add 12. I'm not sure. Let's have a look what I got. I got B was equal to 4A add 10 as well. 4A add 10. That's what I got. And a lot of you got that as well. Lovely stuff. So I guess what I'm going to say, here's a couple of tips for you. Make sure you go back over today's lesson and do the review exercises. We've written some more tricky ones in there. Very important you do more than just what we do in the half an hour. If you just do the half an hour, I don't think it's enough to get it stuck in your brain. You need to do the review exercises. I forgot to post yesterday's one in my meltdown, so I'm going to post yesterday's PDFs on Gradient Line 1. I'm going to post today's PDFs right now, straight after the session. Make sure you do them. Tomorrow, we're going to do some equation of a straight line, and I'm going to teach you a new way of doing it that you may not have seen at GCSE. So you may have seen y equals mx plus c. I'm going to touch on that, but we're going to also do a different way that's actually more useful. So I'm going to cut it there today because you've got a bit of practice to do. We got through today's unscathed. It was good. You did a great job today. I'm really, really proud of you guys. And we will catch up tomorrow for more equations of a straight line. Make sure you like the video. Make sure that you subscribe and you share with your friends. And also, Mr. Arnold, if you can post in the Numerise link, we got so many kids going to Numerise, probably some of your brothers and sisters who are moving from year 6 to year 7, primary to secondary. Please make sure that if you've got younger brothers or sisters, they have a look at this. It's top drawer stuff. We're doing these sessions to help you out, but that could help the younger kids out. All right, Mr. Arnold's going to post it there at the end. So really, really proud of you guys. Can't wait to see you again tomorrow. And yeah, it was nice to do a good session today without all so many boo-boos, wasn't it? Take care, guys. Bye. Bye, bye, bye.